Hi, we're back again, third installment of today's lecture. And let's see what we've done. We were given the marginal revenue and the marginal cost. It said find the X value that maximizes profit. We knew that the marginal profit is dP over dx. If I set that equals 0, I get a critical point. Remember CP? Now that point could be either a max, min, or something else. Horizontal inflection point, etc. Now MR is dr dx and marginal cost is dc dx. So if profit equals revenue minus cost, the marginal profit has to equal marginal revenue minus marginal cost. So instead of finding the profit the revenue function and the cost function, then the profit function, which is a long process, because if you find the revenue function, then you got to find the constant. If you find the cost function, you got to find the constant. It becomes a long problem. Save yourself a lot of grief by just saying dP dx is marginal revenue minus marginal cost. You have those. Make sure you subtract them properly. And you set that equal to 0, dP dx, and you get 25. Once again, that's a critical point. That doesn't tell you you're at a maximum. So what I'm going to do here is find out when I can go right down to here. Find out if this is a maximum. Well, we'll have two ways of doing this. I use the first derivative sign test or the second derivative. This is such an easy function. Let's use the second derivative. Okay, well I now have dP dx equals 150 minus 6x. Oh boy, that P was... The second derivative is d squared p dx squared. Now, we call this p double prime x. That's good for you. This is p prime x. And this is simply going to be what? Well, that's 0. This is minus 6. Notice this is always less than 0. So this tells you for this function, this is at a maximum. So because of this function, now, what do we know? X equals 25 is at a value that maximizes profit. All right. That's all we really wanted. I could use the first derivative sign test also if I wanted to. And okay, so let's do another one, because this is a favorite problem. This one comes from your homework now. Okay? So I'm stealing one from your homework, worksheet chapter 12.13. And let's see, I don't know which number this is, but you can figure it out. This is, of course, 12.4 section. I got the marginal cost equals 1.01 x plus 190 to the fourth 90. Marginal revenue is 1 over the square root of 2x plus 1 plus 2. Now x is going to be the number of units times 10 to the third, so in thousands. And R and C equals dollars times 10 to the third, thousands. So we use a shorthand for this. Now what do they want? We're also given fixed costs equals 100.2, well, actually 100, 200. But for our situation, since it's in thousands for this problem, and be very careful about this because they do like to throw these on an exam. For this problem, we look at fixed costs as only 100.2. Okay? Because this is measured in thousands. All right. And our constraints, these equations only hold when x is less than or equal to 180,000 units. So when my manufacturing or my production system produces more than 180,000 units, these equations no longer hold. That's what they're saying. This only holds for this, actually from 0 to 180,000 units. I could do this if you want to. Okay, this is more. Okay, those are everything that's given. So what do you want to find? Well, in this case, for this problem, we have to do the long, dreadful method. Okay, and here's what they want. Find the revenue function. Find the cost function. Find the profit function. And find the x that maximizes profit. Now I can find this right away if I wanted to do marginal cost minus marginal revenue, but they want us to find these anyway, so we might as well wait and let's take it in steps. So we've got everything here. I just want to put here that fixed costs was $100.2, which I might not remember, and x is less than or equal to 180,000.
And what's this one here?
100, no. Oh, it's on 100,200. But because it's measured in thousands, it becomes this.
Oh, because of this here.
Yes.
Gotcha, okay.
Yeah. Be careful, because if they use 100,000, they're going to get super large numbers. It's going to become a bear of a problem.
Right. Just have to remember that x
Yes.
has to be multiplied by.
At the end, you got to multiply everything by
10 to the third.
10 to the third, or 1,000.
Order of magnitude, yeah.
Okay, so let's find revenue first. Well, I know the marginal revenue is dr dx equals 1 over the square root of 2x plus 1 plus 2. Well, obviously I have to change that one around because I cannot do anything with the square root. So I'm going to say, let's make this dr dx is 1 over 2x plus 1 to the 1/2 plus 2. Let's bring that up into the numerator to make it an easier to do. 2x plus 1, 1/2 plus 2.
Minus 1/2.
Oh, minus 1/2, right. Thank you very much. Change the sign as you go to the numerator. All right, multiply both sides by dx. So you have 2x plus 1 to the minus 1/2 plus 2 times dx. And we'll do it all at once. dr equals distribute the integral of 2x plus 1 minus 1/2 dx plus the integral of 2 dx. Now this is a simple power integration.
You got 4 minutes.
Okay, is it a simple power integration? It's a chain rule, isn't it? You have a minus 1/2 here, you don't have 1. Or a 6 or a 7. Is this going to be a chain rule? Anytime you have a power there, and then a binomial raised to a power greater than 1, you need a chain rule there because you have a binomial there, not a simple x, y term. So let's see what we do here. So for the first term, we're going to use the chain rule of integration. We'll call that A. So I want to put A in here first. Call this equation 1. So for A, well, we look at the integration chain rule. A is 1. U is 2x plus 1. N equals minus 1/2. Notice we're not doing exponentials now. F of x equals what? 1. F of x would be here, and that's only 1. So du dx is 2. Substituting in equation 3 there, rule 3, we get that r is going to equal, we'll make it an r of x, a, which is 1, u, n plus 1, which is the powers minus 1/2. How much time we have?
Okay.
Oh.
3 minutes. I was just waving to the audience.
Oh.
You said a hand would appear.
The magic hand. Give me a hand, please. Okay. And f of x is going to be 1. And du dx is going to be 2. Okay, that's right from here. So this becomes, let's bring back the u. This is minus 1/2 plus 1, which is 1/2. We'll bring back the u, 2x plus 1 to the 1/2 times 1/2, right? All right, that comes from the fx over du dx. That's going to be plus c, right? Now, I don't need the c here because I'm going to substitute back in here. Remember we said beginning, for every one equation, we only use one c. Since I have 2 terms, I'm only going to get 1 c. So I don't need to put this here right now. All right, so what's this going to become? Well, this is 2 over 1. It's going to be 2 over 2, right? Bring this up to the numerator split. It's going to be 2 over 2. 2x, is that 2?
2 over 1, you mean?
No, 2 over 2. It's 1/2 times 2. 2 over 2. You're going to get here, well, you want to do it out this way? This is going to give you 2 over 1 as you multiply times 1/2, right?
Right.
Okay, yeah, I skipped the step, I know. I shouldn't have. 2x plus 1 to the 1/2.
1 minute.
Okay, I'm going to substitute that into, this is A. I'm going to substitute that back into here. So let me rewrite this.
We might have to spill over into a 4th video here.
For this section?
Complete this one, yeah. Because we only have like 30 seconds left.
That's all?
Yeah.
All right, so Rx is going to be equal to, that's 1, right? 2x plus 1 to the 1/2 plus the integral of 2 dx, which is 2x plus a constant. That gives me my R of x.
I have to stop this here.
Can we go further on these?
We'll just do a 4th one for a few minutes. We'll finish it up.
All right, well, this has got more to go, though.